Welcome to Terrible Lizards, a podcast about dinosaurs with Dr. David Hone and Izzy Lawrence. It's the questions episode. It's my favourite episode of the series, and particularly this episode because Dave gets told off by a 3-year-old. Hello everybody and welcome to Terrible Lizards. It is the best of all of the episodes because it is the questions episode, and Dave is so excited to hear all of your questions, aren't you, Dave?
Well, I've heard them already because I read them when you sent them to me.
Oh, shh! No, they're all a complete surprise.
But there is a surprise because I didn't read most of them because there were so many. I got bored after the first page and a half.
It's not bored, it is overwhelmed with excitement about dinosaurs.
Yeah, also that. It was rapidly transparent we were never going to get through even half of these, and there was no point me reading all of them in advance. Plus, it's more spontaneous, so...
Oh, exactly. We'll try and get through as many as absolutely possible. And also, maybe we can do another one of our brilliant lives in the gap between series. Maybe Christmas lives? Can we do it at Christmas, Dave? Can we do it at Christmas? Because you're coming around my house, hopefully.
Possibly.
So we can do it then.
Yes.
Possibly. Yes. So everybody, make sure that you wash your hands.
I think we've established in this relationship who's the overexcitable 8-year-old and who's the weary parent conceding.
It will be fun. You can come round my house and I can feed you dinosaur because it is Christmassy to eat dinosaur. So we have so many questions to get through. Thank you so much to all of our patrons and everybody else who's been supporting us this series. Your constant loveliness has been amazing. If you want to help us as well, do leave us a review because wherever you're listening to this, if they have a view, like on Apple Podcasts, that helps spread the word. How many T-Rex are we worth out of Diplodocus if you use your emojis? I think that'd be quite fun. Just have loads of reviews with just loads of T-Rexes on it, just to prove that you can rar. That'd be a lovely thing to do. But anyway, if you don't know what to write, because I never know what to write, I really like this podcast, it is good. Yeah, obviously it's good. You gave it 5 stars. Give it some T-Rexes. Anyway, okay, so this is probably my favourite question, and I want to open with it because I read it twice. I still didn't quite understand it, and then I think I understand it now. It's amazing. Okay, first of all, it's by Elaine, and she calls us dino friends, which, yes, and she describes herself as a professional dino nerd. And it says, "Hey dino friends, I've got a question for Dave in regards to the recent papers and articles about dinosaurs on the moon." I know, dinosaurs on the moon, and it's not stupid. Okay, hang on. Most things I've seen reference dinosaur fossils being found on the lunar surface, but to my understanding, these specimens should not be fossils. If the asteroid impact sent pieces of dino, RIP dinos, out to the moon, shouldn't they still be in some capacity original material? Since they wouldn't have been buried in sediment and presumably not had much of any environmental decomposition from microbes/weather, do you have any idea what might have happened to these specimens over millions of years? Do they exist at all? How badly do you want to go to the moon and study these dinos? So when the asteroid hit and it blew up all the material, including loads of dead dinosaurs, did those dead dinosaurs end up on the moon, Dave? Is that what happened? Please tell me it's true.
I'm waiting for you to take a breath because I think you did
it's
that
amazing.
Almost in
I'm so excited. I'm genuinely, this is the most amazing question ever.
Yeah, and I'm afraid I suspect my answer is going to be extraordinarily unsatisfying. Mostly because I can't answer most of it because I just don't know. So yeah, a number of people have suggested at various times that is there enough shockwave power to basically get a dinosaur into orbit, but not so much power that it would completely atomize or burn up in leaving the atmosphere. And I'm not sure anyone's actually attempted to calculate that, but assuming the answer is yes, there is no reason to think that chunks of rock, I mean, there are Earth meteorites on the moon, is my understanding. In other words, stuff has hit the Earth in the past with sufficient force to knock stuff off the Earth and then it lands on the moon. So that at least happens. Whether or not that happens to any dinosaurs or whether or not they get there intact, it's not like the lunar rover has picked up a Triceratops skull and gone, look what we found.
I was thinking more like feathers, and it wouldn't be a skull, would it? Because there'd be nothing to decompose the flesh. So it might still...
I mean, I'm sure going through the atmosphere at a few hundred miles an hour will do some serious damage to whatever's trying to get through. I think you need to start with, like, something the size of a sauropod, and you're only going to get a bit in the middle left over when it's gone through that. But assuming that happened, and assuming it makes to the moon, the central part of that question is, they're not going to be fossils. They're not going to have been buried, and it's very eventually under dust. It's been 65 million years, but they have probably not undergone much mineralogical activity because the lunar surface isn't very geologically active at all. There's no weathering going on, and there's some dust and meteorite impacts, and simply sitting in that stuff.
I mean, the sun's quite intense.
Yeah, there's going to be some geochemical processes, but I think it's mostly inert. But as I say, I'm running out so fast because, remember, my background is zoology. I have no geology background at all, and this is ultimately a hardcore geology question of what would happen on the moon. And I know nothing about the moon, and I know almost nothing about the process of fossilization because I'm a zoologist. So that's why I don't really know.
I think geology means of the Earth, so I'm not sure about that. I'll have to look that up. That is the best question ever, Elaine.
It is a great question, and I'm sorry for my pitiful answer, which could be entirely wrong, but that's my best understanding.
I think it is. Yes, if you go to the moon, you can have Velociraptor steak. That's beautifully
Velociraptor
preserved.
died out at least 3 or 4 million years before the extinction. In fact, I think more like 10,
true.
So that's your first problem.
Fair enough.
But anyway.
This is from Michelle. I have a question for Dave also.
Yeah, no questions for you coming in, I notice. I have to do all the work here.
No. Wait for it. Wait for it. Mister, this is my podcast and Izzy just is my dog's body. No, Izzy questions coming up. Okay, I have a question for Dave also. I somewhat recently watched a documentary on the legal battles of Sue the T-Rex in the US. Sorry, I don't remember the name of it.
Dinosaur 13 is the name of it.
Can she get your thoughts on it? Maybe you could just talk a bit about the process of what happens after you find the location of where you want to dig. I was also wondering if you had any disputes over specimens you found. Apologies if you already discussed this and I haven't gotten there yet, Michelle.
So I got to see a preview of Dinosaur 13 before it was shown in the UK, and I was asked to write a review for it for the Picture House Cinema chain, because they show lots of documentaries and stuff like this. And the review I wrote, they said, was unpublishable because they, quote, wanted people to come and see the film. So my thoughts were not particularly positive. I will say it is very interesting to watch. Some of the historical information is quite important. It's not a great piece of work as a documentary in general, and I think there are some fairly serious problems with it, and I'll leave it there. But in terms of the legality, we have talked about this before. In fact, we definitely did some of it in series 1.
Oh, I wasn't listening.
Yes, I know. And I can't remember that far back, but we definitely did something on it. But yes, there are innumerable legal wrangles. You may know there's stuff going on at the moment about some Brazilian fossils in Germany, as part of a more broader thing, which you'll know at the British Museum, and other stuff about repatriation of material that was sourced from various places and what's called scientific colonialism, basically going in and going, oh, here we are, our intrepid Western scientists entering these quiet third world backwaters, and well, they don't know what to do with these dinosaurs, so we'll just dig them up and put them in our museum, and that's fine, because they're ours now. And obviously, some of that happened a long time ago, but equally, bits of that are kind of happening still now, and there's obviously all kinds of questions about there's not questions about how ethical it was, because it wasn't very ethical then, but there's obviously lots of questions about quite how it should all be managed, etc., etc., etc. The short version about digging stuff up is it varies hilariously, and not just from country to country, but even within countries on different bits of land and different bits of laws. So one I always dig out, I don't know this 100% for sure, but I was told this when I was in Germany, that apparently Bavaria has different laws to the rest of Germany about owning and digging up fossils. So not just it's German law, it's local Bavarian law. Certainly in the UK, we have differences between private and public land, but then there's various degrees of protection on bits like the so-called Jurassic Coast in the southwest. Lyme Regis and all the Mary Anning stuff comes from that. Canada, for example, so fossils in Alberta, which is obviously heaving with dinosaur fossils in Alberta belong to the state, whereas that isn't necessarily the case in other provinces of Canada. And then there's this weird thing in Albertan law where if you find a dinosaur on public land, you can dig it up and keep it, but the understanding is that you are keeping it in trust for the state. So you can't give it away or sell it or trade it. You can give it to a museum if you want to, and I think you can bequeath it to your descendants, but it doesn't really matter. But it's this weird quasi thing where you can both kind of to own it, but also not own it. So I've been to a bunch of bars in Drumheller, and they've just got a little cabinet in the window, and it's full of Tyrannosaur teeth that the barman dug up, and he just put them there. But he technically doesn't actually own them.
So it's like having children or something. Technically, you don't own them, but they are yours.
Yes, more or less. And then in the US, which is obviously where most people think of, in general, if it's on private land, it's yours. If it's on public land, it's the government's. What caused the problem with Sue, which is what Dinosaur 13 is about, is that it was found on private land, except thanks to a quirk of law, that private land had been either bought or leased, or there was something to do with the ownership, whereas the owner had got some grants through a Native American program to protection of Native American lands, because he himself was part, I don't know, whatever First Nations nation he was from, and therefore the government actually had a say in the ownership. So it was a rare situation where, although the land was private, the government had a vested interest in it. So that's the first part. And then the second part is, once it had been sold, it became apparent that it was hilariously more valuable than the owner had ever been led to believe, because it turned out to be a very large and very complete T-Rex. And he'd sold like the rights to this for like $10,000 or even $100,000, but, you know, Sue sold for millions. And so that was really the basis of the legal wrangle, is, was there a fair deal in place because the government had a vested interest in it, and therefore the owner didn't have sole rights to his own land. And that's why it got so complicated. But in terms of where we dig things up as paleontologists, well, we dig on government land if we have a license, and we dig on private land if we have a signed legal contract with the owner. And other than that, we're not doing it because it would be illegal. And that's pretty much all you can do.
Talking of digging, okay, we've got a question here from Lee Butler. It is number 7 of his many questions.
Oh boy.
Well done, Lee. I'm going for number 7, only because, Lee, we've got so many questions, I don't want to do it. But I thought it was quite a good one. So it's Cryolophosaurus.
Oh.
Yeah?
And
the big fan.
Yep.
Yeah, exactly. And other dinos have been discovered in the Antarctica. In the Antarctica. I said that, he didn't. He said in Antarctica. But I added the to make it, you know,
more special.
It's that
like
one.
You.
It is that one, yeah. What are digs in Antarctica like? What about other hostile environments? So have you ever been down to Antarctica and done a dig?
I would dearly love to go to Antarctica just to go there.
You like penguins, though?
I'm not sure how much I'd want to go digging. I know a couple of people who have, and their description of it is fundamentally pretty miserable.
Could we get some of them on the podcast and interview them? Because I think that would be fantastic.
I was thinking about this the other day, actually, because one of them is Thaisa Rodriguez, who's a Brazilian paleontologist who specialises in pterosaurs, and Thaisa is a very old friend of mine and works on the ornithochirids, which are the one group I've never really looked at in pterosaurs at all, partly because they're a complete mess and horrible to work on, and partly because she's written this giant monograph completely revising all of it, so no one else needs to go near this horrible mess. So we could try and get Thaisa on at some point, and I know she's been down there. But basically, yeah, Antarctica, very hostile environment. It's unbelievably hot in the day and then unbelievably cold at night, and there's, even in summer, there's risks of freezing temperatures and snowstorms. I heard tell of an expedition down there, well, it would have been 4 or 5 years ago now, where they went for like 6 weeks and had something like 3 days actual digging because a storm just unexpectedly descended and just covered everything in snow, and they just sat in their tents for 6 weeks and then went home, and that was it. And this is why people don't dig in Antarctica very much. I mean, the most hostile stuff I've done is, you know, in the
penguin attacks.
Well, no, not overly in China, which is where I was thinking, but certainly being out in the desert in Inner Mongolia and North China in the I've forgotten the name of the bloody desert now. I was about to say Namib, but that's South Africa.
Not Gobi.
Yes, the Gobi. Sorry, yes, it's the southern part of the Gobi. Thank you. Yeah, it's not that hostile, but it's been 50 plus degrees centigrade during the day, which is warm when you're walking.
I mean, you get hot at like 20 degrees.
Yeah,
though.
I know.
You're one of those people.
So the worst thing that happened to me, and it's almost something that would sound like a hallucination. So I was out one day with Jonas Schwanier, who's American, but now works in South Africa. He's in Johannesburg. And he and I were out together because obviously you always go in pairs everywhere because it's safer. ludicrously hot day and literally wearing a pair of sandals and shorts and sunglasses, and that's it, because the heat is just phenomenal and there's no shade anywhere. And out of nowhere, we got hit by a hailstorm, and these were big chunks of ice, like the size of my thumbnail. Not like little piddly rubbish hail that we get in England, but like proper lumps of ice coming out of the sky very, very fast and very, very hard. And we're not even wearing t-shirts. And these things hurt. And we're running around, like, trying to find anything to sit under as possible cover from this.
It was just each other. Did you just try and climb under each other?
Yeah, no. Just getting battered, and sand, like, cratering up when it hit. And it cleared in, I want to say, like a minute. And we walked back into camp a couple of hours later and told people, and they just didn't believe us. It had been some weird, isolated hailstorm. This one bit of the Gobi, where 1 minute, we're standing around trying not to sweat ourselves to death in the heat, and the next one running to shelter from chunks of ice that were battering us. It wasn't fun, certainly.
Well, I think that answers your question, though, Lee. We've got a similar
Cryolophosaurus.
Cryolophosaurus, there we go.
Because it's cryo-frozen, lopho-crested saurus reptile.
There we go. So we've got a question about that, right? Could you explain how you guys think Cryolophosaurus would look like? Thanks, guys. Love you, Hunter. Also, used a little T-Rex emoji there, so we're worth at least one T-Rex from Hunter. I think people should leave reviews for more T-Rexes in our reviews. Then we know they'd listen to this episode specifically. So if T-Rexes emojis, I just want to see them in our review section. I think it'd be hilarious. Sorry.
Do we know what it'd look like? Well, yes and no. It's the standard answer for something that's pretty incomplete. We've got a fairly good skull of Cryolophosaurus. I don't think we've got very much else, but in that regard, it's a fairly standard early theropod body plan. So it, as far as I know, it doesn't or wouldn't have had particularly long legs or short arms or a weird tail or anything like this. And then, it's got this beautiful little fan crest, almost like a kind of cartoon scallop, with 5 or 6 little slightly semicircular ridges fanning out. It sits in the middle of its nose, just in front of its eyes, and curls over slightly forwards.
Like in the 80s, they used to put in your ice cream, those little waffles.
Yeah, a bit like that.
So on your nose.
Yeah, so that's what it's got, and that's its really exciting feature. And I know we're back to the same old default, but it's almost certainly some kind of socio-sexual selection signalling thing. It's hard to imagine it's really doing anything else. So I'd be surprised if it wasn't a relatively bright colour or stark contrast white against a black background, or had some stripes, or could blush with blood flow or something. But I'm afraid you're not getting any more detailed description than that. Generic theropod with a weird nose thing.
See, I want to know, like, obviously, whether it was be like feathers around it, so it'd come through the feathers, and you wouldn't know.
Well, it's from one of those early lineages which we never thought had feathers, but now some people think maybe they do, but there's no skin, and it's in the wrong kind of rocks to preserve that. So there.
There is the best answer, I think. So Sabrina is asking us a question. Thank you, Hunter. Hello, Dr. Hone and Izzy. So you don't have a first name. You're just like, mate, and I'm just, and Izzy. I'm basically the dog of this episode. Anyway, I have a follow-up question to the episode you did recently about birds being dinosaurs.
Yes.
Why is there such a push to say that birds are dinosaurs rather than just that dinosaurs are a paraphyletic group that excludes birds? Is it just because dinosaurs are so cool that we want them to still exist, or is there some evolutionary reason that birds are dinosaurs more than, say, snakes and lizards? I know that some people are adamant that all taxa should be monophyletic, but as far as I can tell, there is not a push to change the public consciousness about other familiar groups in similar situations. Nobody's got a comedy bit to blow people's minds about whales being ungulates, right? I'm going to write that bit now. Anyway, I love the show. Looking forward to future episodes. Thanks, Sabrina.
Well, where do we start?
I want to feed a blue whale a polo. That's what I want to do, and prove that they are horses.
See, now there's
they're not
there's
horses.
the first. Well, right, so there's the first point.
They're more like elephants.
Well, no, I'm going to end up answering this backwards, but in a sense, that last line has actually sort of exposed what I think is the underlying crux of all of this. So, for anyone who doesn't know, monophyletic is basically a true evolutionary group. The standard definition of anything in science or biology is, you basically draw a line on an evolutionary branch and say this and all its descendants. So, all mammals ultimately came from a single ancestor. And so when we say that birds evolved from dinosaurs, that means birds are dinosaurs because they evolved from dinosaurs. And all dinosaur descendants would include birds. But therein lies the rub when it comes to the difference between the public perception and scientific usage, and in particular the use of technical scientific names. And ungulate is a common term for hoofed animals. But whales ultimately derived from a group called the artiodactyls, which is deer, antelope, giraffe, camels, and cows, and a bunch of others. Whereas horses are traditionally regarded as ungulates because they are hoofed animals that chew and have long digestion times. But they're in the perissodactyls, and they are a different group. And therein kind of lies the problem. So yeah, we do now know that whales are ultimately artiodactyls. They descended from a group who are relatively close to modern hippos. That doesn't mean that whales evolved from hippos, it means their ancestors were close to. But yeah, there was literally a paper about this last week or the week before saying that scientists had coined this new name and replaced Artiodactyla with Cetartiodactyla to include Cetacea, the whales. And it's but we don't need that. Artiodactyla includes whales by definition. It's kind of weird, we know, but Artiodactyla by definition includes whales. And so it's exactly the same analogous point about dinosaurs and birds. I think the difference is dinosaur as a name, dinosaur as a common English anglicised usage name, has pretty much by definition an identical scientific name in Dinosauria. It's almost impossible to separate the two. Whereas, short of a museum, or scientific literature, you would never come across the term Artiodactyla. You just wouldn't. And I think that's kind of the difference in that dinosaur and Dinosauria are basically synonymous, and if we're using them synonymously, birds are dinosaurs. And while you're right that whales are Artiodactyls, they're not ungulates because ungulates aren't a scientific thing. That is a common term. Again, snakes and lizards there is Serpentes for snakes.
Lizards is just too big. It's just too massive a group.
But lizards so snakes also sit within lizards, but lizards don't really have a single true scientific name with that direct exact correlate, which then causes the confusion. And so ultimately I think that's where all of this folds back into itself. And I think it's because dinosaur and Dinosauria are effectively identically synonymous in a way that things like Lacerta and Reptilia and a lot of these other usage of words aren't with a lot of other groups, though Reptilia is its own problem because of birds. But yeah, that's kind of it. But also the flip side is you could just argue that different people have different priorities. I don't see the mammalogists really having a massive fight with the general public about them and about the origin of whales, possibly in part because A, the vast majority of the general public have no idea that whales ultimately evolved from artiodactyls. And B, once that evidence came out that they were, it became established really pretty fast, whereas, and with a great deal of consensus, whereas as we've discussed, there's been, at least initially within the scientific community, and though it has waned, there are still a handful of people who argue that birds are not dinosaurs. And this argument has been leapt on by various creationist groups to argue against science and really use dinosaurs and birds as the crux of their argument. And so I think those are also reasons why paleontologists like me are more vested in getting the public to understand that birds are dinosaurs in a way that, for example, modern herpetologists are not that bothered about trying to explain that snakes ultimately belong within lizards and that whales belong within hippos, because it doesn't really matter.
It doesn't make sense, that, Dave, because hippos are much smaller than some whales. So, moving on. Phil wants to know. So he said, hello, Izzy and Dr. Hone. Backwards. You guys have discussed a few times, I believe, concerning hair-like proto-feathers in both dinosaurs and pterosaurs, and have also discussed the possibility that the origination, that's a word, of these structures may be conserved to back before evolutionary split of the Ornithidaria between the two groups. So, have there been any comparison studies in the preserved photofeather and pycnofiber?
Pycnofiber.
Of course, yeah, because it hasn't got... I can read, guys. Have there been any comparison studies in the preserved photofeathers or pycnofibers, impressions of them, in the two groups to determine similarities or contrast to figure out more of the evolutionary history? Phil?
No. That's the really short, blunt answer, and it's extremely annoying. So, yeah, for anyone who's not quite followed that, Ornithodira is the name given to the group, which is dinosaurs and a handful of their ancestors plus pterosaurs. So we're talking about the point at which pterosaurs split from dinosaur ancestors. And there is a fairly strong idea that since pterosaurs do have filaments called pycnofibers, and we see them potentially in very early theropods and maybe ornithischians, as we discussed recently with Heterodontosaurus and others, that this origin of feathers actually goes outside of dinosaurs and is older than that. And therefore, if that's true, wouldn't you expect a few perhaps unique structures to be true of both pterosaur filaments and dinosaur filaments? Therefore, you should look at both. Yeah, you absolutely should. I put that on the table as a postdoctoral grant proposal 10, 12 years ago now and got turned down.
And nobody does what you say. This is annoying.
And I don't think anyone's done it since. There's been one paper published looking at more detailed structures in pterosaur fibers, but it was part of a bigger study, and so they said, oh, we've got some really good new extra samples and we're looking at them, and that was 5-6 years ago. Nothing's come out since. Part of the problem is there's basically 3 or 4 pterosaurs with really good pycnofibers preserved, 2 of which are in Russia, and obviously it's very hard to get there and access specimens and then do what this would ultimately be is destructive sampling. There is no trivial way of getting this stuff without levering it off the slab and therefore permanently damaging the fossil. I would argue the trade-off is worth it, but that's tricky. A couple of the others are in China, and the same general problem applies. We have, actually, in the grand scheme of things, huge numbers of feathered dinosaurs compared to filamented, or at least well-preserved filamented pterosaurs, and then very few pterosaur researchers, coupled with, China obviously been very difficult to get to. Well, everywhere's been difficult to get to during COVID, but, museums are more protective of particularly well-preserved rare specimens, and those pterosaurs absolutely fall into that category, which is then kind of a problem. Whereas if we had hundreds of rubbish preserved pterosaurs, but the feathers were, or filaments I should say, were quite good, I think people would have leapt on it instantly. So yeah, we really, really, really need to do that, and it's very, very, very annoying that no one has really gone for it, and yet here we are.
Now this, wait for it, guys. I'm very excited about this because David Lowe writes, I have a question for Izzy.
Bye.
If you decided to make a career change into paleontology, what would you want to specialise in? Is there something Dave mentioned that you would really like to know more about? And I would say I would study the difference in protofeather and pycnofibers in early pterosaurs and dinosaurs, just so I could sound really clever, because that would be really interesting to see where the origin of feathers began. I don't know. I mean, would you consider me capable of any sort of study into don't see... You pull a face.
Do you really want me to answer this on a record and then put it out in front?
Well, I mean, the trouble is I've got very short attention span. I'm also quite clumsy. So, yeah, I've done big, multivariate statistical analysis before.
That's more than I've done, so at least not without help.
I'd like to make broad assumptions, data crunching stuff, so I can just, I'd be good. So I'd be able to sort of really categorise. I want to get to the bottom of where the Saurischian Ornithischian divide is, and because that bothers me like nothing else.
Well, that'd be fun.
The idea that the theropods and the Saurisschia, obviously, the theropods are in the group of the Saurisschia, weirdly, and it just doesn't make sense to me on a... Like, if I was just in lining up your toys, it doesn't make sense. And and therefore must be wrong.
So you just want to go and look at pelvies, basically?
Yeah, I just want to look at... I mean, I'm pretty good at looking at pelvises. This is, I am interested in hips. So, yeah, that's what I would do. I would look at the pelvises, or I would look at early feathers. So...
Do we have to flag this episode as not safe for children now with your pelvis innuendos? I'm really quite interested in looking at pelvises.
That is a perfectly decent part of the body to be interested in. You can get a lot of information out of pelvises. In mammals, you can usually tell, if a human, for example, is male or female by looking at their pelvis. Obviously, a deceased one.
I was going to say, I assume you're talking about skeletons, because generally it's...
Anyway, so moving on. This question is from my kids who are 3 and 7s, reworded a little. So, first of all, we got feedback from Leo, who is 3. The Raws in season 4 are lacking a bit of, ardeur. So they're obviously a bit of a season behind. So I'm hoping that the last episode's Raw, because there were 4 of us doing a Raw.
Oh, yeah.
And I think, and a bit of a squawk as well. So I think we've got to, I think we'll take that to heart, Leo, and I think we'll definitely up our roaring for the next series. Were there any, oh my god, Pseudotsuchians? Pseudotsuchians, thank you. Or other lineages of Archosaur?
Archosaur.
Yeah, I said Archosaur.
You said Archosaur as if it was...
Archosaur. I was making sure there wasn't an extra letter in there, because they sneak up on you. Right, that revealed dinosaurs in a given location or habitat during the era of dinosaurs. And Quantum Robin, a question, what is the most exciting, groundbreaking discovery in recent times? E.g. since feathers on dinosaurs were discovered to be a thing. And that's from Kristjan Vega.
Well, they're 2 very different questions. I'm not sure quite why you've lumped them together. Oh, I suppose because it's the 2 different kids.
Yeah, it's 2 kids.
Sorry. Now I get it. So the first one, Pseudotsuchians, so crocodilians and various crocodile-like relatives. So the most obvious one to talk about is a site that was found in, I want to say it's in Niger, so Western Africa, where basically it was crocodile-dominated. So if you imagine something like, if you look at the modern world, odd isolated places can end up with odd faunas. So lemurs are all on Madagascar, kangaroos and indeed marsupials generally are mostly in Australia or Australasia, giant tortoises in the Seychelles and Galapagos and stuff like this. In this case, it appears to have been a desert environment, probably with some water somewhere near the middle of it. And you can imagine, I haven't read up on the details, but you can easily imagine that, new deserts form. That's a very hostile environment that comes up pretty quickly. Some animals may be trapped behind by this forming at certain locations, or maybe, trek across the desert and find a new environment. If you get there early, you've got the chance to radiate and adapt and be able to basically push out any subsequent invaders. This is the classic idea behind Darwin's finches. They got to the island, no birds, they evolved to adapt to all these local things, and then other finches, if they tried to get in, well, everyone's already a specialist. You won't do anything better than they already do. And in this case, in the Niger site, that appears to have been the crocodiles. They got there before the dinosaurs. And so there's a whole bunch of different crocodile species which have all diversified, and basically no dinosaurs. So there's a big galloping carnivorous crocodile, which is presumably fulfilling the theropod niche.
A galloping crocodile.
Yeah,
galloping.
You got to remember, modern crocodiles are weird because they've adapted for a semi-aquatic lifestyle. Ancient crocodiles, there were plenty of fully terrestrial animals, so they had their legs under the body and they stood upright.
And they galloped.
And they'd look more like a weird quadrupedal dinosaur than what you would normally think of as being a crocodile.
They would look like a Victorian dinosaur.
But yeah, pretty much. And so, yeah, that we absolutely have a handful of these places where, in the way that, monkeys aren't in Madagascar and the lemurs do all of that, the crocodiles were doing all this stuff and the dinosaurs weren't. So definitely. And then the second question is, what's the biggest discovery?
I mean, you're not allowed to say it's 2 species of Spinosaur found. It's not that.
Fantastic new 2 baryonyx kinds. Yes, and there's giant and very incomplete Tyrannosaur from China. Yeah, I'm struggling because I think everyone always wants to know about the thing, and of course science is always incremental in lots of ways. I mean, even the feathered dinosaurs, in hindsight, we already had good evidence that Archaeopteryx was a dinosaur and therefore feathers were around somewhere. It was just a question of quite when and where and what, and then those questions start to be answered. So yeah, it's struggling to look at things in isolation like that. If I could change the question slightly and therefore cheat a bit. I'd say it's almost like the technological innovation, and just, it sounds trivial, but just like the internet, which I'm sure for anyone half my age and younger, the world without it seems incomprehensible. But while I was doing my PhD, when email was pretty normal, sending big files wasn't normal. And the vast majority of the way you got your information for research was the library. You walked up to the library every month and you pulled down every journal journal off the shelf that was in your field and you read the list of papers at the back, and if something looked interesting, you took it to the photocopier, you photocopied it, you took it back to your office and read it. And if you didn't have that journal, you didn't even know that a new paper existed. Maybe someone would email you, or there'd be a chat room and someone would go, hey, did anyone see the new X paper on Y? And you'd go, wow, who has it? And they go, I've got it. Great, can you send me a copy? And they'd go to their photocopier and photocopy it and put it in the post and send it to you.
And it would take like a day.
And a couple of weeks later, it might show up. And then you discover that it's not actually very interesting and didn't contain the information you wanted. And like, that's how we did everything. And now I go like, oh, I really need to check that stuff, you know, and I had boxes and boxes of stuff, all with labels and indexes and stuff written, all those spines and all in sections and subfolders. And then, of course, that never works because you get a paper on like Tyrannosaur feeding biology, and do I put that in my ecology folder, or do I put it in my Tyrannosaur folder, or do I put that in my predation folder? And so you never find it again. And now it's just like, oh, I know there was a paper a couple of years ago on that subject, Google Scholar, dinosaur predation. Oh, here's a list of the last 50 papers published on that subject, and I just click on them and download them. And it's like something that used to take me days and might not be very useful takes me seconds and almost inevitably answers the question. And you think about what that's done across, or obviously not just dinosaurs, there's not just many of us, but just like science or even academia, include your historians and geographers and everything else. Like,
oh yeah,
hundreds of thousands, millions of researchers worldwide have now had a major part of their job go from taking days to taking seconds every year. Just think about what that does for productivity and allows you to be more effective and more comprehensive in what you're doing and share information.
I'll add to your answer, which is also just the ability for computers to crunch numbers. I mean, you were saying previously it took days for a multivariate regression analysis to take, to get going, to work out all the links and the correlations between different dinosaurs and their structure, their bone length, etc. And now that process, which previously would have taken days, you can usually get done within an hour just because the computer is fast.
Yeah.
It's amazing.
All of it.
So there we go. Okay. So this is from Russell. Okay. I've invented a time machine. Well done, Russell.
Okay.
You clever boy.
Let's have a go.
Yeah. Do you get one go each before I embark on a time bandits-like pillage through existence? Where and when do you go? Hunt the blue and white Tyrannosaurus rex with the spots that we've already established is definitely real. Find out what Spinosaurs do in the water. Do velociraptors taste like chicken? Where do you go, Dave? What do you do?
Yeah, you see this question semi-regularly, and with my interest at the moment, it's fairly inevitable, for me at least, which is late Cretaceous, probably North America, simply because I know T-Rex gets all the attention. It's always T-Rex. It's like, yeah, but I do work on Tyrannosaurs, and I would like to see a T-Rex. And conveniently, we've got giant Ashdarkids at the same time, which are also something that I'm very interested in. And although it's questionable at quite when and where it popped up, you've probably got Alamosaurus knocking around as well, which is one of the biggest sauropods of all time, and I have interest in body size and maximum size of dinosaurs. So I've got the big pterosaurs that I work on, the tyrannosaurs that I work on, a giant body size that I work on, all simultaneously. And then you've got things like Triceratops with the horns and the frill and the signalling, which is something I'm super interested in. So although those are some very obviously like big ticket famous items, and therefore this sounds incredibly cliched that that's where I'd want to go, it actually genuinely aligns with almost all of my research interests. So that...
There, that's definitely the place. I don't know where I'd go. I think I'd quite like to see those big sauropods laying all those eggs in those Indian... Oh,
titanosaurs, and that's the thing. It's like, if I had to pick one, you'll notice I strategically picked one that would give me about 6 different things.
Yeah.
There's so much.
I'm thinking I'm less likely to get eaten and more likely to get stomped on there, so I'm feeling a bit safer as well. Going to Mongolia and seeing all the little fluttery things, but then you might get done by a volcano. So it's like...
But that's the thing, like the Iszi and would be fantastic, all the feathered dinosaur beds from China, simply because how well does the reality line up with what we've got in the fossil record? That would be amazing to see. It's like, oh, we've missed dozens of species that we didn't know about, or actually we've got nearly everything. This is perfect, but we don't know.
I mean, going to somewhere like the early to middle Jurassic could be interesting, just simply because we don't have many fossils.
Yeah, it's the middle Jurassic is that, that big dead time. And not only is it a horrible time where we've got all almost no fossils. It's when almost all of the big radiations happened. So we're missing the origin of birds, the origin of ankylosaurs, like the origin of ceratopsians, like all these major groups are just getting going and we don't see it properly.
I think if I take my iPhone camera and just walk around those different areas for a bit, just to get an idea of a few of the animals. There you go. That'll do.
The other one I'd love just for something different is the Solnhofen. So the German beds that Archaeopteryx is from. We've got a couple of small theropods, but otherwise basically no dinosaurs. So it looks like it's pretty safe. You've got a subtropical lagoonal system full of coral reefs, Archaeopteryx, some little piddly dinosaurs, some little piddly theropods. Okay, there's some big crocs and stuff in the water, but nothing too dangerous to humans, and innumerable pterosaurs and all the different species, and just when the pterosaurs are radiating as well. So that would be a very nice set up my beach hut, get my binoculars and my camera out, and I'll just watch pterosaurs for a month on a beach. That would be pretty sweet.
I would like, from a personal thing, which is not dinosaurs, unfortunately, but also just to go to Doggerland, which must be just over 8,000 years ago, when just before that got wiped out, and all the human civilization on this one bit of land, which basically got flooded and, was completely inhabitable after this sort of massive sea slide. That's not right, is it? It's a landslide under the sea slump? Something like that.
Yeah, it's got a term.
Yeah. We're not geologists. But yeah, that'll be a fascinating place to go, if not a bit early, for... there are extant species of dinosaur then. Probably a lot of storks. Okay, this is a very quick one from Janet. Did dinosaurs go rawr?
Well, we've kind of done sound before, and so the answer inevitably is maybe, and again, alligators and crocodiles roar, not in the way that a lion does, but they produce sounds which are surprisingly similar in the grand scheme of things. So it'd be odd indeed if at least a bunch of dinosaurs weren't capable of that. So, yes.
Well, I want to ask this next question. I'm going to pronounce Shuyi's name wrong. I think it's Shuyi, but I'm not 100% sure. Shuyi?
Don't know. Depends which language base.
Exactly. I don't know which language either. So Shuyi asks, I always wondered how the scientists decided that Spinosaurus had a sail and not a hump on its back. And Steve underneath has written, I was just talking to my wife about this. Of course you were, Steve. You've got an excellent life partner there. After seeing a buffalo skeleton. I'd like to hear the answer to this as well. So how do you know a Spinosaur, which has this fan, isn't built like a buffalo, which also seems, from the layperson, to have a similar fan spine that's actually got its hump?
The obvious answer to this is you should know better than me, because the last time this came up a couple of months ago, I told you I couldn't remember, but I knew Darren Naish had written an article about it, and I sent you the link.
Oh yeah, you did, didn't you?
So I can't remember the answer, but I know where it's found.
Ask Darren Naish.
Extremely unhelpful. But yes, so at Darren Naish's Tetzoo blog, he literally wrote a piece a few years ago about spines in dinosaurs, and not just Spinosaurus. There's a bunch of others that have these similar expanded plate-like spines, which superficially at least look like what you see in things like buffalo and also even in camels. And it has been argued at various times that these were fat deposits. For reasons I literally can't remember, he does explain why we think that they're not going to be fat deposits, but I can't tell you. But this is the secret of knowledge. This is why we have the thing of kids should be allowed calculators in exams, because if you know what to do and how to do something, that's just as important as the actual mechanics of pushing the buttons in the right order. So yeah,
but you can't take Darren everywhere with you. This is the thing.
But that's why he wrote it down. To quote Henry Jones Sr. in Indiana Jones and the Last Crusade, I wrote it down so I wouldn't have to remember.
There you
Happily,
go.
he did. So, sorry for the lame answer, but equally, the answer is out there.
We will put a link to that in the show notes.
We can find it after all this, or it's all getting edited out.
That will be fine. Okay, so Constantine wants to know why there were no dinosaur analogues of whales or at least seals. They had plenty of time to invade the water, I guess. Now, my feeling of this is because there were already marine reptiles and there wasn't much space for dinosaurs.
Yeah, I mean, eco-space, literally. This is what we talked about with Kirsten when we had her on. In the Triassic, you've got 8-9 different lineages going back into the water before dinosaurs have really got going, and are more than a handful of very similar theropod-like things knocking around in a few deserts. They had more than enough time to go into the water, but against fierce competition.
Mosasaurs.
When whales evolved, and other things like seals and sea lions and walruses and manatees and dugongs and stuff like this. This is post-KT, where they'd all been knocked out and a lot of the big sharks had gone and a lot of big fish had gone as well. You had that eco space, it was a space in which species weren't doing a job.
A job vacancy.
Pretty much. And so, yeah, they had these opportunities. Now, the question I think is perhaps more pertinent is why don't we see them in more river systems and things like that? Because there's an awful lot of stuff like there's otters and otter shrews and platypus and, innumerable small mammals that have gone into aquatic systems. And we even see, Castrocorda. We've got one doing it in the Middle Jurassic alongside dinosaurs, and they're not doing it. So that for me is the more weird question, is not why they didn't invade the seas and become very whale-like or even seal-like, but why they weren't getting into some rivers and lakes when, again, there appears to be at least some eco-space for that, given what some other mammals were doing. And again, much like the crocodile example from earlier, you're always going to get, new lakes or new rivers forming. Species have got to get to these new systems, mini extinctions of local environmental impacts and stuff like this that should have provided them a few more opportunities than we see. And that, for me, is rather a surprise.
Yeah, I mean, maybe because they preserve really badly, there's a lot more frogs doing those jobs than amphibians. Just as a thought. Anyway, Matthew wants to know, is a pterosaur question allowed?
Yeah, of course.
That, Matthew? Is no. Oh, okay.
I like the pterosaurs.
Yeah. So he wants to know if there is any evidence of some sort of pterosaur of prey, i.e. a species that predated primarily on other pterosaurs.
No, and that's also, I think that's more of a weird one, because pterosaurs were around for such a long time. It's weird that they didn't evolve some kind of other pterosaur predating pterosaur specialist. Of course, on the other hand, it's quite possible that they did, and we just don't recognise it because we're too busy looking for something that's more like a falcon than pterosaurs actually are or were capable of being.
Because if you look at, for example, gulls, we don't sort of consider them birds of prey, but they do eat, primarily other birds.
Some of them will eat a lot of, and yeah, it's tricky to say, and it's there's always that risk that you simply won't conceive of what's happening. So, for example, you think of a bird of prey, something like a peregrine falcon or an owl, for that matter, is hitting stuff with its feet. It's got these big feet with these talons, and it's coming down and it's smashing and grabbing stuff, and then it's ripping them apart with that super hook beak. Well, pterosaurs don't do that. We've got very
few feet.
We've got very few. Well, they can't grasp with them really, and they've got very few pterosaurs with sharp foot claws, but also their wings are integrated with their legs. So if they swung their legs down or forwards to try and grab something, that's completely changing their wing shape. Whereas with a peregrine, it's adding a lot of drag, dropping the legs out of the slipstream and in and down, but it's not fundamentally changing their wings and their lift and everything else. So that might be a serious problem. On the other hand, I could speculate insanely and go, lots of pterosaurs have really big claws on their hands, and pterosaurs have a wing membrane. So why not fly up behind it and just rip its wing with your hand? Now, it's a lot harder than that, I'm absolutely sure, but that would knock them out the sky. You don't need to grab them at that point. You just need to graze them as you go past, in which case we probably wouldn't see any different adaptations in their hands than other pterosaurs which are just good at climbing trees, which would have all the same reasons to have all the same grip and claw shape and curvature and sharpness that would also be useful for predation. And then, pterosaurs don't have bird beaks. Well, I mean, I know pterosaurs have beaks, but they don't have that same jaw shape and structure. Their neck structure is very different. So a pterosaur couldn't swallow another small pterosaur whole, because that would be very difficult. And they're also not very well suited to grabbing a pterosaur and pulling chunks off in a way that a lot of birds are.
They're basically only good for fish and tubes.
Yeah.
I mean, this is the thing about Quetzalcoatlus, right, which is the largest, obviously one of the largest, and it could only swallow maybe a newborn baby sized thing.
Yeah, it doesn't have a big mouth.
Just put a sombrero on your kid and it's safe.
Yeah. But
choking hazard.
But thinking about it again, with bird specialist bird predators, so again, things like peregrines, what they really like doing is going for the pectoralis, these giant flight muscles that we've talked about in birds before. Pterosaurs don't really have that, or at least, to be more accurate, not to the same degree, because birds have put their up muscles and their down muscles on the front, and pterosaurs and bats, rather more sensibly, have their up muscles on the back where you'd expect. But that means that you don't have such an enormous block of chest muscle on a pterosaur that you would on a comparable sized bird, which might mean that they're harder to feed on and you get less return for your effort. And again, birds often have very muscular legs, which pterosaurs absolutely didn't. So there are these big blocks of relatively easy or relatively accessible muscles on birds, which are, I mean, not insubstantial on a flying pterosaur. Obviously, it could fly, but perhaps rather less than a bird. So again, speculating wildly, but the combination of harder to grab them because you can't really do it with your feet when it would screw up your wings, and you'd get less food when you have done it, might make it pretty tricky.
Cool. Now, Craig, I'm going to ask this one. I think it's one of our last ones looking at the time, but I'm going to get this in because I think it's a cool one. Here, it's a couple of questions, but I want to ask this one. I would assume that the majority of dinosaur fossils will be found just under the KT boundary, as this was the bad day for everybody 66 million years ago. How hard is it to find fossils from times prior to the KT boundary, as there were many millions of years of life before the KT boundary? So I think this is a misconception that a lot of people have, is that all of our dinosaur fossils come from that one big death event.
Yeah, I think the problem is, although decay, and we mentioned this before, decay is a big thing. We were talking about the moon. If a fossil has...
We were talking about the moons. Yeah. There's been a good episode where we were talking about the moon.
Yeah, in order to make a fossil, your organism needs ultimately to be buried in something. And the more intact it is when it's buried, the more of it you'll get back. So on the one hand, yeah, the KT event is going to be very, very good at killing lots of things and stopping them breaking down, because you've killed all the scavengers and you've probably done the bacteria not a lot good either, etc., etc., etc. And that's going to help stuff become fossil. But what's infinitely more important than that, and is really going to drive everything, is the burial action. And that's far, far more important. You've got to be buried. And it's not like the KT would have killed lots of things. It's not like it's suddenly caused all the rivers everywhere to start producing lots of extra sediment and bury things very carefully. And it also doesn't mean that those rocks of that time period are exposed on the surface, which is what we need them to be. They need to, first, your animal needs to die. Well, it doesn't need to die, but if it gets buried,
it will
before
do.
That, it's not great. Yeah, quite. So it needs to be dead. It needs to be buried. It needs to, not decay to the point that there's nothing there. It then needs to, actually fossilize. Yeah. And not erode or be destroyed, because the continents are moving and plate tectonics will subduct stuff and destroy it, or it will go under a mountain, or a mountain will form over it, or whatever else, or a river will run through and just erode it and destroy it. And then it needs to be back at the surface by all those 65 million years of rock eroding down, and then we need to be able to access it. And from that point of view, the KT event, even if you want to call it a few thousand years, but really in terms of that death and lack of predators things, we're talking about years at best, decades maybe, not thousands and thousands and thousands of years, is a geological blip of the tiniest amount in the 150 million years that dinosaurs were around. And therefore, it's not special in terms of making fossils. And even if it was, it's going to be ludicrously outweighed by the vast amount of time and the rest of the globe in terms of accessibility of these fossil sites. So, yeah, it really doesn't make a difference.
And there you have it, ladies and gentlemen. If you want to be preserved, you're going to have to find a really good bit of, a desert.
Deserts are ideal because, you just break down in rainforest.
And this is what happened. I mean, this is why you had all of the, Egyptians deciding they wanted to preserve themselves, because the first Egyptians who buried themselves or got buried in the desert basically mummified due to the lack of water and conditions. And then it was only when they got into tombs that you had to do all the preserving things. You naturally mummify because you're in a wet, sealed environment and you rot. That's why they had to hook your brain out your nose and all the rest of it. Yeah. I hope all your children are eating right now because they love a good old hook your brain out your nose Egyptian mummification story. Anyway, so preservation, it's all about, the luck of the environment. And just because you got a lot of dead bodies does not mean you're going to have a lot of fossils. Does not correlate.
Almost certainly helps. It's just going to help a couple of percentage points against far, far, far bigger factors.
And then you have a large area of the Yukon, is that right? The
Yucatan
Peninsula?
Yeah.
Yucatan. That's going to be completely destroyed anyway. So where it actually hits,
yeah, I mean, that's going to
get...
it's just going to vaporize stuff. Yeah,
exactly. And maybe you're going to get dinosaurs on the moon. So I'm just obsessed with that.
Yeah, there we go.
It's a long way for it to go.
But we're back to well, the thing is, once you've left the atmosphere, if you've got any momentum, that's it's space now. That's all you needed,
I suppose. But it's still like the moon is a long way from the Earth. It's a long way, and that's a lot of dust going.
But again, 65 million years, even at a mile an hour,
it's going to get there.
Yeah, it's absolutely going to get there. That would be fun, wouldn't it? If it turned out that what actually caused the malfunction in Apollo 13, a T-Rex tooth went through one of the engines.
That would be I mean, we should write the movie right now. That would be amazing. Anyway, so I hope, Dave, that you have your most amazing roar. You've got to really go for it, because we have been told off by a 3-year-old that our roars have not been good. Also, ladies and gentlemen, I just want to say thank you very much, boys and girls. Thanks y'all for everything. You've been brilliant. Do please keep supporting us on Patreon. If you want to leave, if you don't want to say in a review, I want emojis. I want dinosaur emojis. You can put a chick in there if you're big on your avian dinosaurs, but just let us know that you are enjoying the podcast. Tell your friends about it. Your support is why we're doing this. We'll be back in the new year at some point, I'm sure, won't we, Dave? Yes. It's not like we're all completely stressed and have 1,000 jobs. It's fine. It's going to be good. We will be back. We will have more. Dave is doing an impression of Wallace from Wallace and Gromit.
But with more hair. Yes.
A bit more hair, yes. So, yeah, just a massive thank you. Do please support us on Patreon, because that does basically pay us for our time and make us want to do this. And, yeah, we can get it out to you. So thank you for everybody who does that. And, yes, do spread the word. And until next series... This episode of Terrible Lizards was made possible by our generous patrons on Patreon. To support the show and for bonus content, please go to patreon.com/Terrible Lizards. For links to everything, including merch and past episodes, go to terriblelizards.co.uk. Please follow us both on Twitter. I'm at ISZI_LAWRENCE and Dave is at DAVE_HONE. Send us your questions either via Patreon or terriblelizardspod@gmail.com. If you can't afford to support us on Patreon, please do write a review and recommend the show to your friends. Thank you so much for your support. It means a lot to us.